Hello, this is Dr. Oz. Today I will talk about a minimization problem in linear programming. And first I will talk about problem formulation, and I will show you a chemical company example and find the solution for that. All right, so let's move on to the next slide. So in this problem, I would like to start with an example. M&D Chemicals, they produce two products, product A and product B, to sell these to raw materials manufacturer companies to produce soaps and laundry detergents. A and B products should be sold. At least we need to have 350 gallons of products next month. Plus, in addition, another requirement here is a major customer asking us to produce at least 125 pounds of product A. And the processing time for product A is 2 hours per gallon, and product B is 1 hour per gallon. For the upcoming month, I have only 600 hours of processing time. So I'm trying to solve this problem. Again, this is a production problem here that could be generalized for bigger size problems. All right, so let's take a look at here. The production cost for product A is $2 per gallon and product B is $3 per gallon. Looks like product B is more expensive. So as you guys know, a optimization problem should have three components in general. 1, the objective. 2, decision variables. 3, constraints. So let's start with the objective here. So objective of this model, since I don't have any profit or revenue information here, I only have cost information, I would like to minimize the cost. And to minimize the cost, I need to write the equation for the cost. So what's the equation for the cost? The objective function here is minimize 2A, because every A product cost me $2, plus 3B. Perfect. All right, so the second component here is decision variables. I need to figure out what my decision variables are. So let's define our decision variables. A is number of gallons of product A to produce. And B is defined to be, again, number of gallons of product B to produce, right? These are my decision variables. So let's go to the next slide. So let's write our model all together here. This is a minimization problem. I'm trying to minimize 2A plus 3B, which is total cost, subject to, these are my constraints. I want to make sure that 1A is greater than or equal to 125 pounds. Why? Gallons. Why? Because that's a demand for product A. And we gotta make sure that 1A plus 1B should be greater than or equal to 350. This is the total production requirement. And these are greater than or equal to, because at least I need to produce that much. And I have resource available for me, which is 600 hours of processing time. So every A production will require 2 hours, and every B will require 1 hour. So that has to be less than or equal to 600 products. And also I have non-negativity constraint, which is my decision variable A and my decision variable B has to be greater than or equal to 0. So this is my model. Again, if you look at this model, you will see that I have an objective, which is a minimization function. And these are the coefficients, and these are my decision variables. Again, decision variables have to be part of your objective function. And these are my constraint coefficients. You can see coefficients here, and you can see decision variables here. Again, I need to have my decision variables on my constraints left-hand side values. And the right-hand side values here are given, and these are the relationships that I need to define. Once I'm done with that, I can translate this into Excel and I can solve it. That's it for this video. Enjoy business analytics.